Hello BSRT2 students, welcome back to our virtual classroom. Again, this is RT212, this is radiation production and characteristics under our topic, atom. So this day we will discuss all about the fundamental forces of nature. Okay, so once again, good morning. So let me start my discussion by reading the introduction. So prior to understanding the forces involved in radiation production, it should be first understood that the forces of nature ranges from the inner space of an atom to the outer space of the universe. So in the perspective of medical physics, there are four fundamental forces of nature, of which emanate from the level of atomic interaction. So before we could understand radiation production, of course, it says that radiation production is the atomic level. So we have to first understand the existing forces of nature. And that, again, most of which involves atomic interaction. Okay, so we have a question. How many forces of nature are considered fundamental? Is it letter A, 2? Is it letter B, 3? Is it letter C, 4? Or letter D, 5? So if you still remember the previous slide, so we said that there are four fundamental forces of nature. And we have to know them in this section. So there are four fundamental forces of nature, three of which are the electromagnetic force, strong force, and the weak force. So these forces are involved in keeping stable atoms in one piece and determining how unstable atoms will decay. So remember that the term decay because it will be carried over next week, especially when we discuss radioactivity or radioactive decay. Okay, so basically, before we could understand the radioactive decay, again, let me reiterate that we have first identify or first remember the fundamental forces of nature. So, three of which are at the atomic level, the electromagnetic, strong, and weak nuclear forces. So, the electromagnetic force keeps electrons attached to their atoms, and the strong force holds the protons and neutrons together in the nucleus. The weak force governs how atoms decay when they have excess protons or neutrons. The other fundamental force, which is the gravity, becomes apparent with objects much larger than subatomic particles. Question: what is the weakest force among the fundamental forces of nature? Is it letter A, strong force? Is it letter B, weak force? Is it letter C, gravity? Or letter D, electromagnetic? Not because we have mentioned the weak, it's already the weakest among the fundamental forces, but it is the gravity. Okay, remember that? So, okay, gravity is the weakest of the four fundamental forces of physics. Approximately 10 raised to 38 times weaker than the strong force, 10 raised to 36 times weaker than the electromagnetic force, and 10 raised to 29 times weaker than the weak force. So as a consequence, it has no significant influence at the level of subatomic particles. In other words, walang pakialam si gravitational force sa atom. Okay? So, in contrast, it is the dominant force at the macroscopic scale and is the cause of formation, shape, and trajectory or orbit of astronomical bodies. For example, gravity causes the Earth and other planets to orbit the Sun. It also causes the Moon to orbit the Earth and causes the formation of tides, the formation and evolution of the solar system, stars, and galaxy. And this is all credited to the discovery of Sir Isaac Newton with the universal gravitational force. So, again, gravity is one of the two forces which is visible to the human eye because the other force will be discussed in the next slides. Okay, next question. What force causes unlike charges to attract and like charges to repel? Is it letter A, strong force? Is it letter B, weak force? Is it letter C, gravity? Or letter D, electromagnetic? So if you answered letter D, you got it right. So electromagnetic force causes opposite electric charges to attract each other, and the electromagnetic force becomes stronger as the distance between between charges becomes smaller. So in physics, we will discuss sooner or later about the Coulomb's law, in which the greater the electrostatic charge of either object, the greater the electrostatic force. So the electrostatic force is very strong when the objects are close, but decreases rapidly as objects separate. So we have the formula to find the net force, either attraction or repulsion, which is equivalent to charge 1 multiplied by charge 2 divided by the square of the distance between them, which is multiplied by a constant proportionality known as the the constant proportionality K. So it's out of range for this topic, and that will be discussed next semester. Okay, so the kind of force which causes like charges to repel. So this kind of force again causes electric charges to repel each other. The negatively charged electrons repel one another and tend to move far apart from each other. But positively charged nucleus exerts enough electromagnetic force to keep the electrons attached to the atom. So remember the charges again: positive for protons and negative for electrons, and neutrons have no charges. So in our illustration, we have two particles, both are positively charged. So as you can see in the arrow, so their force of attraction, force between them is repulsion, not attraction. So both charges repel and unlike charges attract. Okay, very good. Next, we have, it is most familiar of the forces at work inside the atom. This is the same force that causes people's hair to stick to a brush or comb when they have build up of static electricity. Okay, so as I've said earlier, there are two fundamental forces which are visible to the human eye. One is the gravity, and the second is the electrostatic force. Example, again, hair rising experience when you brush or comb due to the static build-up of electrons here. And we also have an example, as you can see, this is a radiograph this is what we call the static artifact. This is an artifact which is primarily caused by handling and storage of X-ray films. Static artifact, this is caused by build-up of electrons in the emulsion, and this is noticeable during periods of extreme low humidity. Pag masyadong malamig yung panahon, so there is build-up of electrons. And there are three distinct patterns of static, which is the crown, the tree, and the smudge. And of course, that will be discussed in the photochemistry and film analysis. So again, what I'm trying to say here is if there are attraction or repulsion, like build-up of electrons, so it is an example or an evidence of an electromagnetic force. Next question. What force holds the protons and neutrons inside the nucleus of an atom? Is it letter A, strong force? Is it letter B, weak force? Is it letter C, gravity? Or is letter D, electromagnetic? If your guess is letter A, then you are right. It is strong force. So protons and neutrons in the nuclei of an atom are held together by the strong force. This force must overcome the electromagnetic force of repulsion because the protons in the nucleus exert on one another. Remember again, based on the electromagnetic forces, that both or like charges repel. So inside the nucleus of an atom, we have the protons, and they are positively charged. So there are tendencies of electrostatic force of repulsion, but thanks to the strong nuclear force, they are being held together inside the nucleus, which is not easily breakable, kaya nga strong. The strong force that occurs between protons alone, however, is not enough to hold them together. So other particles that add to the strong force, but not to the electromagnetic force, must be present to make the nucleus stable. And the particles that provide this additional force are very good. These are neutrons. So thanks to the presence of neutrons, which make up or build up the nucleus, which is the center of the atom. Okay, so next question. What force accompanies a change of one atom to another atom? Is it letter A, the strong force? Is it letter B, weak force? Is it letter C, gravity? Or is it letter D, electromagnetic force? So we have one remaining option, which is letter C, which the weak force. So the weak force lives up to its name. It is much weaker than the electromagnetic and strong forces. It affects all particles in an atom. Remember, it affects all particles in an atom because the electromagnetic force only affects the protons and electrons, and the strong force only affects the protons and neutrons. But in a larger sense, the weak force affects all the particles in an atom. When a nucleus has too many protons to hold together or so many neutrons that the strong forces squeeze too tightly, the weak force actually changes one type of particle to another. And this is the basic principle of radioactivity. When an atom converts from one type to another, based on our question, when an atom changes from one type of an atom into another atom. So when an atom undergoes one type of decay, radioactive decay, this is for unstable atom, the weak force causes a neutron to change into a proton, an electron, or an electron antineutrino. One has to assume that upon decay process of an atom, subatomic particles as well as energy escape from the nucleus of an atom. Although this is not what actually happens inside the atom, so this is our example of the nucleus of an atom. If there is a greater force to break the nucleus of an atom, so there is an emission of particles, and probably we can say energy, so that this atom will be now converted to another atom accompanied by an emission of particles and energy. And it is the basic principle, or one of the basic principles of radioactive decay. Okay, so that concludes the discussion of the fundamental forces of nature. As a recap again, so we have discussed the gravity or the gravitational force. We also discussed about the electromagnetic forces, the strong nuclear force, and the weak nuclear force. Now let's come to the combinations of atoms. So as a review of in your chemistry, so when atoms combine, so they form molecule or a compound, in which a molecule is defined as atoms of various elements may combine to form structures called molecules. And in a larger sense, a chemical compound is any quantity of one type of molecule, which will be elaborated in our illustration, which defines that a molecule are the smallest units of a compound that retains the characteristics of that compound. So we have an example there, 2 atoms of oxygen. So that's a molecule, and a compound is being defined as contains atoms of different elements chemically combined together in a fixed ratio, the complex form of a molecule. So in our example, we have the carbon dioxide, which is accompanied in fixed ratio. We have 1 atom of carbon and 2 atoms of oxygen. Okay, so question. What type of atomic bonding is exhibited when there is sharing of electrons? Is it A, metallic bonding? Is it letter B, ionic bonding? Is it letter C, covalent bonding? Or D, none of the above? Okay, so if you answered letter C, covalent bonding, then you are right. Okay, so let's define what is covalent bonding. So in covalent bond, the two bonded atoms share electrons. Take note. Okay, so share electrons from both atoms are in a negatively charged state. Okay, so when atoms involved in the covalent bond are from different elements, one of the atoms will tend to attract the shared electrons more strongly, and the electrons will spend more time near that atom. This is defined as the polar covalent bond. In its opposite version, when atoms connected are the same, neither atom attracts the shared electrons more strongly than the other. This is called a non-polar covalent bond. And when two atoms share a pair of electrons, they form a covalent bond. So when atoms bond covalently, they form molecules. And a molecule can be joined up of two or more atoms, all joined with covalent bonds. Each atom can share its electrons with one or more other atoms. Some molecules contain chains of thousands of covalently bonded atoms. Carbon is an important example of an element that readily forms covalent bonds. Carbon has a total of 6 electrons. So as a summary, covalent bond is the sharing of electrons or negatively charged particles. Because we also have another form of bonding in which the question what type of an atomic bonding happens when an atom loses or gains electrons to complete their valence shell. Is it letter A, metallic bonding? Is it letter B, ionic bonding? Or letter C, covalent bonding? Or letter D, none of the above? So this is now the second type of bonding, which is letter B, ionic bonding. So atoms can also lose or gain electrons to complete their valence shell. An atom will tend to lose electrons if it has too few electrons in its valence. After losing the electrons, the next lower shell, which is full, becomes its valence shell. So an atom will tend to steal electrons away from other atoms if it only needs a few more electrons to complete the shell. Remember, they are types of ions now, class. We have negative ions, if you can still remember, and we have positive ions. So losing or gaining electrons gives an atom a net electric charge because the number of electrons in the atom is no longer the same as the number of protons. So atoms with net electric charge are called ions. Scientists called atoms with a net positive electric charge and ions, and atoms with a net negative electric charge cations. So when these cations and anions bond together, they are now being bonded in a second type of bonding called the ionic bond. So positive and negative, whereas the covalent, they are both negative. Ano? Okay? So the third type involves positive. Both atoms are of positive state. So what type of atomic bonding, such as the atoms in the substance, share each other's outer electrons? Is it letter A, metallic bonding? Is it letter B, ionic bonding? Or letter C, covalent bonding? Or D, none of the above? So, if you answered letter A, metallic bonding, then you are right. So, atoms can complete their valence shell in a third way by bonding together in such way that all atoms in the substance share each other's outer shell electrons. This is the way metallic elements bond and fills their valence electrons. Okay, so as you can see in our illustration, there is the free movement of electrons. Okay, so metals form crystal lattice structures similar to salts, but the outer electrons in their atoms do not belong to any form in particular. Instead, the outer electrons belong to all the atoms in the crystal, and they are free to move throughout the crystal. This property makes metals good conductors of electricity. So that's basically explains why metals are good conductors, because the electrons are free to move they are now called the sea of electrons. Okay, so this is just a short discussion because our intent is to save your mobile data for the purpose of answering the questions or chapter test which is posted in your e-learning portal. I'm referring to the Moodle. So, okay, class, if you have questions, don't hesitate. You may reach me through different platforms. You know that. We have our Moodle, our Facebook, and of course, this YouTube video. So, next week, we will be discussing the radioactivity, which is a prelude to radiation production. And that concludes my discussion. Thank you so much for watching. So like and subscribe for more videos and lectures. Thank you so much. So that is for now, and take care and goodbye.